You know that exact moment right before you have to give a massive presentation to a room full of people. Or maybe, you're just sitting at your desk, minding your own business, and you see an incredibly vague, nerve-wracking email from your boss pop up.
Oh, yeah. The classic "we need to talk" subject line.
Exactly. And before you've even moved your mouse to click on it, your heart is suddenly pounding aggressively against your ribs. Your palms get all clammy. You realize you're taking these really shallow, rapid breaths.
Right. It is an intensely physical experience. And what's wild is that it's triggered by something entirely digital.
Yeah.
There is zero physical danger in that email.
Yeah, it literally cannot reach through the screen and bite you.
Exactly. But your body is reacting as if a literal predator just stepped into your office.
It's so visceral. And usually, when we talk about this sensation, people just casually toss out the phrase fight or flight. We treat it like it's a simple binary switch in the brain. Like you get scared, the switch flips, and you panic. But looking through the research we gathered for today, it is overwhelmingly more complex than that.
Oh, absolutely. It's not just...
Completely under the hood of your stress response. We're going to dismantle that overly simplistic fight or flight cliche and map out the incredible dual-engine physiological cascade that actually takes over your body when it perceives a threat.
Which is absolutely the right lens for this. Because like you said, this response isn't a single panic button at all. It's this highly coordinated, entirely involuntary symphony of neural and hormonal changes.
Symphony, right.
Yeah, and fundamentally, this system is a brilliant evolutionary survival tool. I mean, it was built over millions of years to keep you alive in sudden life or death situations. But, as we are going to explore, it is severely mismatched for the modern world you and I navigate every day.
Because our biology is basically stuck in the Stone Age while we're dealing with Wi-Fi and corporate hierarchies.
Exactly.
But before we get into how this dual engine system is operating inside your body right now, like while you're sitting in traffic or reading an email, I want to talk about how scientists even figured this out. Because the discovery was a complete accident, wasn't it?
It really was. It's one of my favorite accidental discoveries in medicine, honestly. The whole concept really anchors on two major researchers working decades apart.
Okay.
So the first piece of the puzzle came from Harvard in the 1910s and 20s. A physiologist named Walter Cannon was studying animals, mostly cats and dogs, in the laboratory.
Okay. What was he doing with them?
Well, he would expose them to sudden threats, like a barking dog, and then meticulously measure their physiological changes.
And he's the one who gave us the term fight or flight, right?
He was, yeah. Cannon mapped out a very fast, very consistent physiological signature. He noticed that the moment the animal felt threatened, its pupils dilated wide. Blood flow was rapidly rerouted away from the digestive tract and pushed straight into the skeletal muscles.
So prepping for action.
Exactly. The liver dumped stored glucose into the bloodstream for quick energy, and the heart rate spiked. He traced all of this back to the sympathetic nervous system and the release of adrenaline.
Wow.
So he concluded the body was prepping for two logical actions: fight the threat or run for your life.
Which feels completely intuitive, but he only found half the puzzle. When I was looking through the notes, the really fascinating breakthrough didn't happen until 1936 up in Montreal.
Yes, with Hans Salai.
Right. An endocrinologist named Hans Salai was doing research, and he wasn't even looking at stress at all. He thought he was on the verge of discovering a brand new sex hormone.
That's the best part of the story. Sully was injecting laboratory rats with ovarian extracts. He was hoping to document a very specific, localized physiological reaction to this hypothetical new hormone.
But it didn't work out that way.
Not at all. The results were incredibly frustrating for him. Every single group of rats he injected developed the exact same triad of bizarre symptoms.
Enlarged adrenal glands, right.
Yes. Enlarged adrenals, heavily shrunken thymus, and lymph nodes, which are critical for the immune system, by the way. And they developed deep, bleeding stomach ulcers.
And the thing that must have made him want to pull his hair out is that his control group, the rats that were just getting injected with harmless saline, were showing the exact same organ damage.
Exactly.
So he failed completely at finding his hormone. But in doing so, he realized he had found a non-specific response.
That is the crucial insight right there. He realized the specificity he was hunting for just didn't exist in this reaction.
Yeah.
Instead, he had stumbled onto a biological pattern common to any sufficiently noxious stimulus.
Wow.
It absolutely did not matter what the threat was.
Yep.
I mean, it could be a toxic chemical, extreme cold, physical restraint, or just the terror of being handled by a researcher. The body's internal alarm system always produced the exact same physiological damage.
So Salai basically discovered the body's universal check engine light. I mean, if you think about your car, it doesn't matter if you have a bad spark plug, a loose gas cap, or a failing transmission. That same orange light on the dashboard lights up.
That's a great analogy.
Salai found that the human body has one universal biological alarm for something is wrong.
And he actually borrowed a term from physics and engineering to name it. Engineers use the word stress to describe mechanical strain on a bridge or a material. So Salai applied it to biological wear and tear.
Oh.
He called this the general adaptation syndrome, breaking it into 3 stages. First is the alarm stage, which is Cannon's fast fight or flight. Second is the resistance stage, where the body tries to cope with a threat that just won't go away.
And a third.
Exhaustion. If the stressor never stops, your physiological reserves run completely dry, and those very organs, the adrenals, the immune tissue, the gut, they fail entirely.
Okay, so stress is this universal check engine light. Let's lift the hood and look at what is physically happening in your body in the seconds and minutes after that light flashes. Because this pathophysiology is wild.
It really is.
So step 1 is detection. And there is a phenomenon here that completely blew my mind called the stick versus snake shortcut.
Oh, it's arguably one of the most elegant defense mechanisms in our neurobiology.
How does it work?
Well, to picture this, imagine you are hiking through a dense forest. Out of the corner of your eye, you spot a long, dark, curved shape coiled on the path. You instantly flinch, you jump backward, and your heart jumps into your throat.
Yeah, total panic.
But a full second later, you realize it's just a curved branch. It's not a snake. But you moved before you actually knew what it was.
Right. I didn't consciously think to myself, a venomous reptile, I should employ my leg muscles to jump backward. My body just bypassed my conscious brain entirely.
Because it did. The sensory information from your eyes goes to your visual cortex to be processed, but that takes time. To keep you alive, the amygdala, which is your brain's threat appraisal hub, uses a crude, incredibly fast neural shortcut through a part of the brain called the thalamus.
So it doesn't wait for the high-res image?
Exactly. The amygdala gets a very low-resolution image, essentially says, let's vaguely like a snake, fire the alarm right now, ask questions later.
Better a false alarm than getting bitten. So the amygdala hits the panic button. That triggers step 2, which is the fast cascade. The medical term in our sources is the SAM axis,
Yes.
the sympathetic adrenal medullary cascade.
That's right. Within fractions of a second, your amygdala alerts your hypothalamus. The hypothalamus then sends an electrical signal straight down your spinal cord to your adrenal medulla, ordering it to immediately dump adrenaline and noradrenaline directly into your bloodstream.
And the physical effects are instantaneous. When we talk about feeling stressed, this is the machinery doing it. Your heart rate and contractility surge to pump more blood. Your airways dilate so you can gulp down more oxygen. But what I found fascinating is the vascular constriction. Your body violently shunts blood away from your digestive tract and your skin, pushing it all into your large skeletal muscles.
Yes.
That's why your skin goes pale and cold when you're terrified.
It is. And it's also why you get a dry mouth or butterflies in your stomach.
Yeah.
Your digestive system is effectively being starved of blood and temporarily shut down.
Makes sense.
You don't need to digest a sandwich if you're about to be eaten by a lion. At the same time, your liver dumps all its stored glucose into your blood for immediate explosive muscular fuel.
Okay, but I have to stop you here. Because looking at this mechanism, I don't buy that this is sustainable.
What do you mean?
Well, if my blood is constantly shunted away from my vital organs, and my heart is racing at 150 beats per minute, and my liver is dumping all its sugar, I would literally run out of energy and collapse after 3 minutes.
You would.
It's like hitting the nitrous oxide button in a street racing car. You get a massive burst of speed, but you absolutely cannot drive the car to work like that. The engine would melt. So if the threat doesn't vanish in 10 seconds, how on earth does the body avoid shutting down?
That is a phenomenal question, and it highlights exactly why the old fight-or-flight model was totally incomplete. You are correct. You cannot run on pure adrenaline for more than a few minutes.
Right.
Your body would go into metabolic failure.
Yeah.
That is why you have step 3, which is the slow cascade. This is known as the HPA axis, hypothalamic-pituitary-adrenal.
The second engine.
Precisely. While the fast adrenaline cascade is firing off in seconds, the hypothalamus is simultaneously sending a much slower chemical signal corticotropin-releasing hormone to the pituitary gland in your brain.
Okay.
The pituitary takes a minute, then signals the adrenal cortex, which ultimately releases a hormone you have definitely heard of, cortisol.
Cortisol, the infamous stress hormone that every health blog tells you is destroying your life.
Yeah, it gets a terrible reputation, but cortisol is actually trying to save your life.
Right.
Because this HPA cascade takes minutes to hours to fully ramp up, cortisol acts as the endurance fuel.
So it steps in when the adrenaline starts to run out.
Exactly.
Mm.
It keeps your blood glucose elevated so you don't crash. But crucially, it also aggressively blunts your immune system and your inflammatory response.
Wait, why would my body suppress my immune system when I'm under threat? What if I get cut?
Because inflammation is highly metabolically expensive. It requires massive amounts of energy to run an immune response.
Oh, I see.
During a crisis, cortisol basically pauses your immune system to conserve all that energy for immediate survival. And here's the most important part of the HPA axis. Once the threat finally passes, cortisol crosses back into the brain and acts as a negative feedback loop.
It tells the brain to stop.
Yes. It tells the hypothalamus, we're safe now, turn the adrenaline off. Cortisol is the brake pedal.
Okay, so you have this incredibly powerful multi-stage system mobilizing enormous amounts of energy. But here's where it gets really interesting. What happens when that sheer biological power overwhelms the organism it's trying to protect?
It can be disastrous.
Right. Can the survival tool misfire so badly that it actually kills you?
Unfortunately, yes. The medical literature contains some astonishing examples of this machinery causing immense physical damage.
I read about this.
One of the most striking is Takotsubo cardiomyopathy. It was first described by cardiologists in Japan in the 1990s, and it is colloquially known as broken heart syndrome.
And to be clear to you listening, this isn't a metaphor for feeling sad. This is acute physical damage to the heart muscle.
Yes, it is purely mechanical damage, but the catalyst is entirely an emotional shock. A patient might experience a sudden tragedy like the death of a spouse, a natural disaster, or bizarrely, even a massive positive shock like a surprise party. That intense emotional spike triggers a catecholamine surge. Catecholamines are just adrenaline and noradrenaline. The surge is so massive and so sudden that it essentially poisons the heart.
The mechanism here is incredible. The adrenaline actually floods the beta receptors in the heart tissue, right?
That's right. It floods the cells with calcium, which paradoxically stuns and paralyzes the muscle fibers at the bottom of the heart instead of making them pump harder.
Oh, wow.
So the bottom of the left ventricle balloons out while the top continues to contract. It takes on the shape of a traditional Japanese octopus trap, which is called a takotsubo.
And when doctors rush these patients into the ER, they look exactly like they're having a massive fatal heart attack. But when they check the coronary arteries, there are no blockages, no plaque.
None.
The damage is a direct mechanical result of the stress response itself just overloading the tissue.
It is the ultimate example of the fast sympathetic engine revving too high. It also disproportionately affects postmenopausal women, indicating a complex estrogen protective factor that drops off later in life, which we're actually still trying to understand.
That is wild.
But takotsubo is what happens when the sympathetic nervous system overdrives. There is another lethal off-ramp that shows what happens when the body collapses in the exact opposite direction.
So wait, it's not always an overdrive problem. The system can just shut down.
Completely. And to explain this, I have to bring up a frankly deeply unsettling study from 1957 by a Johns Hopkins physiologist named Kurt Richter.
Ah, the rat study.
Yes. He was studying endurance by dropping domesticated lab rats and fierce wild rats into vats of water to see how long they would swim.
And he assumed the wild hardy rats would outswim the tame lab rats.
Naturally. But then he introduced a variable. He clipped the wild rats' whiskers, which removes their primary sensory connection to the world, and he briefly held them tight before dropping them in the water. The result was shocking. The wild rats drowned almost immediately.
They didn't swim until they ran out of energy. They just sank.
Yes, and Richter realized they weren't dying of physical exhaustion. The overwhelming, inescapable hopelessness of their situation triggered a massive parasympathetic collapse.
The parasympathetic system.
Right, which is the rest and digest counterpart to the sympathetic fight-or-flight system. It runs through the vagus nerve.
Okay.
In these rats, The stress didn't make their hearts race to failure. The utter hopelessness made their vagus nerve overdrive, dropping their heart rate so steeply and so fast that their hearts simply stopped beating entirely.
A lethal off-ramp. The body essentially pulls the emergency brake so hard that it snaps the axle in half.
Exactly.
It proves the stress response isn't just about fighting or fleeing extreme. Inescapable threat can cause a complete biological shutdown.
Which brings us to the reality of daily life. You listening to this are rarely facing sudden heart-ballooning shocks. And hopefully you aren't facing the kind of lethal hopelessness Richter's rats experienced.
Let's hope not.
So why is modern everyday stress linked to so many chronic diseases?
Because of how our highly evolved human brains deeply misuse this ancient biological machinery. Robert Sapolsky, the neuroendocrinologist at Stanford, frames this perfectly.
He does.
He spent decades studying wild baboons in Kenya and wrote the famous book, Why Zebras Don't Get Ulcers. He points out that a zebra's stress response is incredibly efficient. A lion chases it, the zebra sprints for 3 minutes. If it escapes, the threat is over. Its stress response switches completely off and it goes right back to grazing.
But humans have the unique cognitive ability to simulate threats in our minds.
And that's our downfall. You can sit on your very comfortable couch, completely safe from physical harm, and run that exact same life or death physiological cascade for 3 straight weeks, just ruminating over that vague, we need to talk email from your boss.
Yeah.
We take a biological system built for a 90-second sprint and we force it to run continuously for months.
And understanding why that is so damaging requires a major paradigm shift in how we view bodily health. Walter Cannon originally framed stress around the concept of homeostasis.
Meaning?
Well, the idea that the body has a fixed, stable set point, like a thermostat permanently set to 72 degrees. When a stressor pushes you off that point, your body mounts a response simply to get you back to 72.
But the more modern research completely refutes that, right?
It does. By the 1990s, scientists Bruce McEwen and Peter Sterling argued that homeostasis was fundamentally flawed when it came to stress. They introduced a new concept, allostasis, which translates to stability through change.
Stability through change.
Right. The body doesn't stubbornly defend one fixed set point. Instead, it constantly recalibrates its operating baselines, your resting blood pressure, your baseline glucose, your cortisol levels, in anticipation of future demand.
So if I am constantly ruminating about work, my brain assumes I literally live in a permanent state of physical danger. So it resets my baseline blood pressure to be permanently higher just so I'm always ready to run.
You've got it. The stress response isn't a temporary deviation. It becomes a predictive adjustment. And this explains the concept of allostatic load.
Right, the wear and tear.
Exactly.
Yeah.
Chronic stress doesn't destroy you with one massive event. It slowly damages you through the immense wear and tear of this constant recalibration. Keeping the HPA cascade running, keeping cortisol elevated, keeping your immune system constantly suppressed, that erodes your health over time.
It's what produces hypertension, abdominal fat deposition, impaired wound healing, and even shortens your telomeres, which literally accelerates cellular aging.
Yes.
So how do we know this isn't just an issue for people who work 80-hour weeks?
Because of a massive epidemiological project called the Whitehall Studies. Michael Marmot led these starting in the 1960s, observing thousands of British civil servants over decades. These were government workers in a very rigid hierarchy.
And they found a massive social gradient in heart disease and mortality. But the shocking part was that it wasn't tied to who had the heaviest workload or the most responsibility.
Right. The disease burden tracked almost perfectly with a person's autonomy. Low control over your daily tasks, being constantly told what to do, having high demands but no say in how to execute them, keeps that biological stress cascade running constantly.
Well, lack of control is the real killer.
Because a lack of autonomy translates biologically to unpredictability. Unpredictability is interpreted by the brain as a chronic threat. High autonomy, even with a massive workload, acts as a biological buffer. Your brain knows it has control, so it turns the alarm off.
That makes so much sense.
And understanding this nuance completely shatters several major pop science myths that dominate the wellness industry today.
Oh, we definitely need to talk about the myths, because if you spend 5 minutes on any health blog right now, you will run into the term adrenal fatigue.
Yes, you will.
It's this incredibly trendy alternative diagnosis that claims chronic stress basically wears out your adrenal glands like an old battery until they just can't produce cortisol anymore, and that's why you feel perpetually exhausted. Biologically speaking, what is actually happening there?
The blunt reality is that adrenal fatigue does not exist in medical science.
Wow, really?
The Endocrine Society has stated unequivocally that there is zero scientific evidence for it as a distinct medical condition. It is a fundamental misunderstanding of endocrinology.
So it's just completely made up.
Well, there's a real rare condition called Addison's disease, which is true adrenal insufficiency, but that is a distinct autoimmune or structural disease. It is not the result of being stressed out at your desk job.
Okay.
Adrenal fatigue is really a cautionary tale of how pop science oversimplifies complex hormones into good or bad or high or low.
Which leads to another massive paradox in the source material. The common myth is that more stress equals more cortisol, and therefore cortisol is the villain.
Right.
But the psychiatrist Rachel Yehuda did some fascinating research on Holocaust survivors and combat veterans with severe PTSD. You would naturally assume their trauma means their cortisol levels are sky high.
You would assume that, but Yehuda found the exact opposite. Many individuals with severe chronic PTSD actually show much lower baseline cortisol than non-traumatized controls.
How is that even possible? If their stress system is broken, shouldn't it be flooding them with stress hormones?
It goes back to that negative feedback loop we discussed with the HPA axis. Cortisol is supposed to be the brakes.
Right.
In some cases of severe trauma, the HPA axis becomes hypersensitive to that negative feedback. It shuts cortisol production down far too efficiently.
Oh, wow.
And here is the brutal paradox. Because you have low cortisol, you have no brakes to apply to the fast sympathetic system.
So the adrenaline is just running unchecked.
Yes. Your adrenaline response is left permanently underbraked. You feel chronically hyperaroused, jittery, and anxious, precisely because your cortisol is too low to shut the adrenaline down.
That completely upends the simple cortisol is the bad guy narrative. It's
Yeah.
not about having too much, it's about the regulatory mechanism being out of tune. And speaking of upending simple narratives, Cannon's original fight-or-flight concept had a massive blind spot from the very beginning.
A massive demographic blind spot. Cannon's animal experiments in the early 20th century were almost exclusively conducted on male subjects.
Right.
For decades, the entire scientific community just assumed that fight or flight was the universal default for all mammals. But in the year 2000, the psychologist Shelley Taylor pointed out this oversight. She proposed a complementary stress response called tend and befriend.
Right, which is driven heavily by oxytocin and is observed much more frequently in females across various species. Under threat, instead of fighting or running, the body releases hormones that promote caregiving behaviors, tending to offspring and forming protective social alliances, befriending.
Because evolutionarily, there is profound safety in numbers. Forming strong social alliances under threat is just as valid a survival strategy as fighting.
Absolutely.
Furthermore, modern clinical trauma researchers have expanded the vocabulary even further, adding freeze and fawn to the clinical shorthand.
Yeah, freeze is the immobilization response, like a prey animal playing dead.
Right.
And fawn is a human appeasement behavior, where you try to pacify or please an inescapable threat, which is tragically common in childhood abuse dynamics. So we're not just looking at a binary switch anymore. It's a complex, multi-tool system: fight, flight, freeze, fawn, tend, and befriend.
Which brings up the ultimate question for you as a listener.
Okay, lay it on us.
If you have this complex, ancient, heavily automated biological machinery running your body, are you just a victim to your biology? When the boss sends the scary email, are you just a helpless passenger on the adrenaline ride?
Fortunately, the research says absolutely not. Your mind is not a passive observer. There is a psychological framework called the transactional model, developed by Richard Lazarus and expanded by researchers like Elia Crum.
Yes, the appraisal piece.
Right. It proves that stress isn't just the external stimulus, and it isn't just your bodily response. Stress is the relationship between the demands placed on you and your perceived ability to cope with them. Appraisal changes the biology.
Hansalai himself recognized this later in his life. He realized not all stress causes damage.
Oh, interesting.
He coined the term distress for overwhelming, damaging stress, and eustress for stress that is motivating and within your capacity to handle. Think about the feeling of playing in a championship sports game or the thrill of going on a first date.
Oh, yeah. You're nervous, but in a good way.
The physiological cascade, the racing heart, the glucose release is nearly identical to being chased by a predator.
But the biological outcome is totally different. If you reframe that massive presentation at work, not as a lethal threat to my survival, but as a challenge that my body is graciously giving me extra energy to crush, You literally alter the downstream hormonal cascade. You don't accumulate the same allostatic wear and tear.
Knowledge is only powerful when you apply it. By understanding why your heart is racing, knowing that it's just the SAM axis mobilizing energy for you, and by focusing on gaining predictability and autonomy in your life, you fundamentally change the biological signature of your own stress response.
So what does this all mean? It means your stress response is a sophisticated dual-engine multi-tool system. It is not your enemy. But its impact on your health hinges entirely on how you appraise your environment and your underlying belief in your own ability to cope.
You are not broken when you feel stressed. Your body is executing a brilliant program that millions of years of evolution perfected. Your job today is just to update the cognitive software so your biological hardware stops wearing itself out on false alarms.
I love that framing, which leaves me with a final, slightly provocative thought for you to chew on after this deep dive is over. We've established that chronic, uncontrollable stress recalibrates our allostatic load upward, causing wear and tear and raising our baseline anxiety.
Yes.
But if our stress response is ultimately a predictive adjustment based on our perceived ability to cope, could you hack it in reverse?
What I mean?
Well, if eustress actually improves physiological performance, could intentionally seeking out short, highly controllable microdoses of physical or mental distress, like forcing yourself into a freezing cold shower, or deliberately taking on a scary but safe mental challenge, could that permanently recalibrate your allostatic load downward?
Oh, that is fascinating.
Right. By repeatedly proving to your brain that you can cope and that you will survive the adrenaline spike, could you actually give yourself a calmer, lower physiological baseline for the rest of your life?
Building resilience.
Exactly. So the next time you sit at your desk and that scary email pops up, your internal engine doesn't even rev. It just idles perfectly under your control. Something to think about.